Okay, so domain and range. Okay, domain is the set of all x values. What other word tells you that's the x? We talked about it last week. Independent. So with domain, it's also independent. They all kind of go together. Domain, independent, x. Okay? Range, set of all y values. So what's the other one that? Dependent. Okay, good. So range, dependent, and y all go together. Okay? So domain is your x. Independent is your x. So domain and independent are both your x. Range is your y, dependent is your y. So range and dependent is your y. Okay? So, now discrete. What discrete means is when we're talking about graphs, I'm going to ask you, is this graph discrete or continuous? And the easiest way to remember this when you're looking at a graph is discrete is they're just dots on the graph. They're not connected by any lines, they're just dots. So discrete starts with D, dot starts with D. Okay? If you say they're continuous, that means there's going to be dots on the graph, but then there's going to be lines that connect them. Okay? So continuous starts with C, connected starts with C. See how I did that? Okay? So discrete is dots, continuous, connected. Now, sometimes you get a thing where it's a word problem, and then I say, okay, is it discrete or continuous? And you have to kind of sit there and really, really think about it because you don't have anything to look at to tell you. Okay, so think of it like this. Discrete is a dot, so it's a set number. So like, trying to think. The way you look at it is you think of it, there is no in between. It's either this number or this number. There's no in between. Whereas continuous means like there is an in between. Like weight. You don't go from weighing like 70 pounds and all of a sudden, boom, in a split second you're 120. It doesn't work that way. You go 70, 71, 72, 73, all the way up. There's an in between. So discrete means there's not an in between. Okay, I'm trying to think of an example for discrete without having to look at the paper. We'll figure it out here in a little bit. Okay? Alright. Is everybody at least down to where it's discrete and continuous? Yes. Okay? Alright, so now there's different types of domain and range. Okay? Now you may have domain and range of graphs, and you may have domain and range of a table. Okay? Now when they're graphs, when they're just linear graphs, right here, or you can see each edge of the graph, that means there's a dot on each end. Okay, it's going to look something like this. Now, you got to keep in mind, you remember the open and closed? If it was just less than or greater than, it was open. If it was less than or equal to, greater than or equal to, it was closed. Okay, so you got to keep that in mind. Now, but if you look, I did a number less than or equal to x, less than or equal to a number. That is my domain. So this one would be domain, because it's dealing with the x. Okay, we said domain is x, right? So then for your range, you would have a number less than or equal to y, less than or equal to some number. Okay, now I put less than or equal to because those are closed circles. So choose that. When you're writing it like this, 99% of the time you're going to use those two right there. Okay? Now if you have a table or dots on a graph, you're going to write it like this. A list of numbers. Okay, so when you have a graph and you can see both ends of the graph, two dots and a line in between or a curve in between, whatever, you're going to write it like the first one right here. And when you have a table or dots on graph, you're going to write it like this. You're going to put D dot dot bracket. And then start listing out your numbers. Now you do not have to repeat numbers. So let's say on your domain you have 0, 1, 2, 2, 4, 4, 6. Well, all you have to write is 0, 1, 2, 4, 6. You don't have to put multiple numbers multiple times. Is that same? That make sense? Same for the range. Okay? So I'm going to show you kind of how to figure out all this range and stuff and figure out, okay, am I going to write it like this, like the graphs, or am I going to write it like a table or dots on a graph, okay? Everybody got that right there? Who's still writing or typing? Okay. I'll give you a second, then we'll go to the next paper. So let's go ahead and get that paper that says Imagine the Possibilities. Okay, it says Imagine the Possibilities. Okay, so it says find the domain or range of each part. So when you look at it, think of what? You got 8 problems, 4 in the front, 4 in the back. Yep. Okay, so let's look at this first one. Okay, first of all, is it discrete or continuous? Discrete. So let's go ahead and write discrete. And why is it discrete? Because it's only dots. Okay, so discrete, dots. They both start with D. So they're discrete and dots. Okay, so now, how am I going to write my domain and range for this? Am I going to write it number less than or equal to x less than or equal to number? Or am I going to do like domain dot dot bracket and list out my numbers? Okay, so you're going to list out your numbers, right? Because it's a dots on a graph, right? So let's go ahead and do this. D dot dot bracket R dot dot bracket. Now if you're wondering where I get the D and the R, take a wild guess. Domain and range. It's just the first letter. And that's how they're going to write it on the STAR test. Okay? Alright, so now let's start with each dot. Yes. Okay, so here's how you do this. You start with the very left dot and you work your way to the right. It's just like reading. Every one of you reads from left to right. You don't read right to left. Okay? You'd be a little different, but it's okay. Okay, so you start with the very left dot. Right here. This one right there. Right there. And you're going to draw a line straight down to the x-axis. Okay? Now, what number do you run into on that x-axis from that dot? That's where you have to kind of figure out. Now, these are spaced out. They go by 2s and they skip. So, obviously that one's 0. Halfway in between 0 and 2 is 1, right? Now what's halfway in between 1 and 2? 1.5. So I'm going to write 1.5 right here and then comma. So that was my first dot. So then move to the next dot. So which is this one right here. What number does that one run into? 2. Perfect. List it. Then I move to the next dot, which is down here. Is it 3? 3.5. 3.5, perfect. Then I move to the next dot, which is way up here. goes to 4. Then I got one way out here on the end. 9, perfect. And then you end with the bracket. Okay, so that's your domain. That's how you find the domains of dots on a graph. You just go from the dot straight down to the x-axis. Because it deals with your x, right? Domain is x. So you go to the x-axis. So how do you think you do with the range? You go to the y-axis. Now, I always start with the very bottom dot and work my way up. So, this one right here. What is that? 0.5. So I'm going to do 0.5, comma. Next dot up is way out here. Now, if you look, your y-axis is labeled a little different. So we're actually wrong on the first one. What's that? It should be 0.25. You got to look at it carefully. Okay, so the next one up would be 0.50, so right here. So 0.5. And then the next one up would be, what's that? 1.5. Next one up would be 3, perfect. And the next one up would be 4.25. Okay, perfect. So that's how you do that with dots on the graph. Draw a line from the dot to the x, dot to the y. Figure out what numbers it runs into. Okay? Alright, let's skip over to number 3. We'll just go side to side so I don't have to scroll up and down a whole lot. Okay, it says when he is driving at a constant rate. Now, what does constant rate mean? Continuous, like it's the same speed over and over. That's what rate is. Rate is a speed. It takes her 4 hours to drive 232 miles from her house in Dallas to her parents' house in Houston. She creates a graph of distance versus time for a trip using the equation D equals 58t. Okay, now, we don't see an x and a y in this, right? So what do you think is going to be the x? The t. Your t, which is time, is your x. So that means your d, which is distance, which is your y. Now, anytime you have an equation, okay, you do it just like you do with the dots, listing it wise. Okay, so you're going to get down here, D dot dot bracket, R dot dot bracket. Okay, now the only thing is you don't have a graph to look at, but you have an equation to work out. Okay, so think about it. It took her 4 hours. So we can make a table of this right here. So at 0 hours, that means she hasn't left yet. How far has she gone? 0, obviously. Okay, after 1 hour, how far has she gone? Take a wild guess. 58. How'd you do that? It's in the equation. 58 times 1 gives me 58. Okay, so after 2 hours, how far has she gone? 116. After 3 hours, how far has she gone?
174.
And 4 hours, 232. Now, if you're wondering how I'm getting these numbers right here, well, I got the 0 and 0 because, well, if you haven't traveled, 0 hour, you hadn't gone anywhere. 4, they tell you, in 4 hours you traveled 232 miles. All we're doing is this, 58 times 1, 58 times 2, 58 times 3. Okay, so now, here's how you write your domain. you list your x. So what's our first x? 0. Second? Third? Fourth? Fifth? Good. There you go. Your range. Okay, the miles, which is 0, 58, 116, 174, and 232. Now here's the question I have. Is it discrete or continuous? Why? Constant has nothing to do with it. You're right, it is continuous. But remember what I told you. Continuous, it's connected. You can have an in-between. Can you have an in-between the mile per hour? Or the miles? Like you don't sit here, leave here, and all of a sudden, boom, you're 5 miles down the road. You got to do the in-between. 1 mile, 2 mile, 3 mile, 4 mile, 5 mile, right? Okay, so it's continuous. Okay, good. Alright, so when we have a graph with dots, we list it. When we have an equation, we can make a table. We list it. Okay, so number 2, how do you think we're going to do that one? Just list. Now, they're already in coordinate form. So D dot dot R dot dot. Make sure you put brackets. If you can't draw a bracket, just draw a squiggly line. That's what I do. Okay, so what's my domain? X values, which are? Do I need to repeat -1? No, you don't have to write it down twice. Even though it's up here twice, you do not have to write it down twice. Okay, then 0, 1, and 2. Perfect. My range. Do I need to repeat the 5s? No. Okay. So, don't have to repeat numbers. Okay. 99% of the time on the STAR test, they don't repeat them. Okay. So, you just got to know which one goes with which. Like this -3 is going with this -2. This -1 is going with this 4. This -1 is also going with this 7. And then 0 goes with, oh, I forgot 3. With 3, and then 1 goes with 5, and 2 goes with 5. You just got to know that. Okay? Alright, now on to the graph. This one's the tough one. Okay? First of all, continuous or discrete? Continuous. Okay, so now we're going to write it, we're going to list it out, or we're going to write it number less than or equal to number, or x less than or equal to number. The less than or equal to x less than or equal to something, right? So then you can go ahead and do this. You can go ahead and list it just like that, or write it just like that. Get that out of the way, because it's automatic almost every single time. This is automatic on x, this is automatic on y. Now we got to figure out our left number and our right number. Okay, so here's how you do this. You go to the very left of the graph, which is over here, and you draw a line straight down to the x-axis. What number does that run into? 0. So I'm going to put a 0 on this left side. Then I'm going to go to the very right of the graph, which is right there. 9.5. And I'm going to put that on the right side. Pretty simple, right? Okay. Some of you are probably thinking, no, this isn't very simple. Okay. Alright, so then range deals with my y, right? So I'm going to start at the bottom of the graph. Very bottom. Right here. Where does it go? 0. That's going to go right there on the left. Then I'm going to go to the very top of the graph. Now, some people always get this mixed up. They want to go right here at 10. How many of you were thinking that at first? But right there at 10. Is that the very top of the graph? No. The very top of the graph is up here where the curve is. So from there, I want to go over to here, to the y-axis. So, what number is that? There you go, 22.5. Okay, so very bottom and very top. Very left, very right. Okay, when you have a graph like this. Okay? Does that make sense? Okay, the automatic is less than or equal to x, less than or equal to. Okay, less than or equal to y, less than or equal to. Okay? And we said it's continuous because it's a line. Okay, they're connected, right? Okay, we're good from there? So far, so good? Okay, let's flip the page. Okay, number 5. Continuous or discrete? Continuous. Why? There you go. Because it's connected. Okay, now I have closed dots. If you can't see them, these are closed dots on the end. So what's my signs? Less than or equal to x, less than or equal to. Less than or equal to y, less than or equal to. Okay, now you do this just like you just did with that curved graph. Start at your very left of the graph. Now, the only thing is, you're not necessarily going down to find, because look at where the x-axis is. The x-axis is right here, and the y-axis is right here. Okay, so from this very left dot, I'm going to go down and figure out what I run into on the x-axis. -6. So I put my -6 right there on the left. Now go to the very right of the graph, which is right here. Now am I going to go down or am I going to go up to the x-axis? Up. And what number do I run into? There you go. There's your numbers. Okay, so now let's do the y. Now, very bottom of the graph to the y-axis. So that means I'm drawing to the left because the bottom's on the right. So you get what? -4. And then, very top of the graph, draw it to the y-axis. 1. Okay? Alright, so number 7. We'll go 5 to 7. 4 equals y equals -4x minus 10 for all prime numbers less than 15. So what does prime mean? 1 and itself. Okay, so let's do this. Now first of all, how am I gonna write this? Am I gonna write this like number 5 or am I gonna list it out? Being that it's an equation. List it out. So let's make a table. Okay, so what's our first prime number less than 15? 1. Is 1 prime? One is not prime because it's only multiplied by itself. It's got to be 1 and itself. So what's our... It's actually 2. It's our first prime number. 1 is neither prime or composite. Okay, what's our next one? 3. What's our next one? 5, perfect. What's our next one? Good. Next one? Not 9. Because 9 you got 1, 3, and 9. 11, perfect. And 13. That's it, right? Okay? Because it says less than 15. So we don't have to put 15 in there because 15 is not prime anyway. Okay, so now we work it out. We got -4 times 2 minus 10. Gives me what? -18. Okay, then -4 times 3 minus 10. -22. -4 times 5 minus 10. -30. -4 times 7 minus 10. negative 38. Negative 4 times 11 minus 10. Add negative 4 times 13 minus 10. Negative 62. Perfect. Okay, domain. Domain or D dot dot bracket, right? And then 2, 3, 5, 7, 11, 13. And then range, negative 18, negative 22, negative 30, negative 38, good, negative 54, and negative 62. Okay. Continuous or discrete? Discrete. Perfect. Discrete. Perfect. Okay. All right, number 6. Okay. A senior citizens group is making fruit baskets and plans to sell them as a fundraiser. They are able to make 10 fruit baskets and want to sell them for $35 each. Okay? So, how are we going to do this? What's that? List them out. Okay, so we can go ahead and do this. D dot dot bracket, R dot dot bracket. So, they made 10. So obviously our domain is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the number of baskets. Now we got to figure out how much they're gonna make. So if they sell 0, how much money do they make? 0. Perfect. If they sell 1, how much? $35. 2, 73. 105. 4. What? 140. 5. 6. 210. 7. 8. 9. And 10. 3. Oh. What's that? 10 would be, we messed up on that previous one. It's not 315. Should be 325. No. Yeah, it's 315. And then 350, right? Okay. Alright, so you would list out your domain 0, 1, 2, 3, 4 all the way to 10. Go ahead and do that. And then put your bracket, and then your range would be your Y numbers. Discrete or continuous? Why? What's that? Well, obvious. Yeah, it's going to keep going, but remember, continuous, there's an in-between. Discrete, there's not. They have a set price, right? So, are you going to make $18? No. Are you going to make $40? No. You're going to make $80? No. There's a set price, $35, $70, $105 that you're going to make. So this is actually discrete. There is no in between. Okay, it's from this price to this price to this price to this price. Okay? And number 8. List it or write it out like a graph. listed dot or D dot dot bracket R dot dot bracket. What's my domain? -3, -1, 1, 3, 5. Perfect. Range? 3.25. Good. 5.25. Good. Discrete or continuous? Discrete. Okay, anytime you have a table, more likely it's going to be discrete. Okay? Anytime you have a graph that's got a line on it, continuous. And then the word problems are the ones that are tricky. Okay? Alright, so that's first day of domain and range.